Yeah. I did have issues the other day into my questions.
Okay, officially it's the start time. So given that I'm broadcasting this on the internet, I'm actually going to start. And the format for the stuff that's going to happen in the room is going to happen down here where the Jetsons are. So if you're actually going to participate in the hands-on, then I'd like you to come down to the front, please. That's fantastic. We've scared one away. Yeah, just come down from where there is a Jetson. So we have way too much equipment in the room, but basically it's Jetsons is what we're using. The Jetsons are the ones who are in nice cases. Yeah. Good morning. Yes, if you take the photo from there, you can make it look as though there were people. So are you participating or are you loitering? Yes, you're participating. Okay. All right. So are you near a Jetson? You're near a Jetson, which is there. Okay. So broadly, the context of this is trying to show the process of getting software built the Baserock way and onto a Jetson, or later on in the hands-on a Raspberry Pi. And we're aiming to specifically deploy the GENIVI demo platform and show that some of it works. So this is a picture that I shared with AGL and GENIVI some months ago. It basically shows the overall pipeline that we're aiming at for production of automotive software in the GENIVI and AGL contexts. And broadly, we're going to be using a part of this process this morning. So the idea of getting stuff from upstream, getting it into Git, using a simple set of tooling to build the Git source into binary objects, and then deploying those binary objects onto a target board. Okay, so the broad concept we're aiming at is that we can do builds both in the cloud and on target hardware. And ultimately, we can do testing on the cloud and on target hardware as well. But the general principle is that we want a cohesive and standardized workflow that helps people to ensure that they know what they're doing, what they're working with, where the source code has come from. So the approach that we're taking is slightly different from the work that was demonstrated in some of the other hands-ons. We're trying to avoid the situation where people are having to install a load of stuff without knowing where it's come from. We're trying to establish a trusted and controlled process, as well as doing the work of delivering the software itself. So we're interested in the infrastructure and the way that the software gets put together, not just hacking on a given day. We're trying to establish that the software can be known to work, know where it came from, and know what it's going to do once it's on the box. So broadly, we're going to be starting the hands-on with a cloud-based implementation. One of the things that we've talked with various people about over the years is that Baserock is focusing on native builds as opposed to cross-compile. And that makes people scared that they need to find expensive or difficult to procure ARM servers. So there's a very simple solution for that now. This is a French company called Scaleway, and they offer real servers in the cloud based on ARM architectures. And the amazing thing is that it's €3 a month for renting a server. So getting a whole server in the cloud, running an ARM-based CPU, €3, that's pretty ridiculously cheap. So what I've done in prep for this, I've created quite a lot of servers, as you can see in that list. And I'd like the people that are interested in actually doing the hands-on part at this point to raise your hands, and we're going to hand out an IP address so that you can actually log in. When we sent out the invites to this, we suggested that people send SSH keys. We didn't get very many of those back. So we've decided to simplify that process. You don't need SSH to do the first part of this hands-on. But what I do need is that you've got a laptop, a browser, and that you're able to access the internet. So if you can satisfy those things and you want to do this next step, I need you to raise your hand and we'll give you an IP address to go to. Okay. Anyone else? Yeah. There you go. Okay, so it's not quite as simple as just putting the IP address into the browser. We've got it set up so that it's a particular port. So I hope that people are technical enough to follow me when I say what you need to do here is you type in the IP address. So in this case, I will be typing in 212.47.234.15. Then you put a colon, and then you put the port number, which is 4200 in all cases. And if you go to that website, that should give you a prompt saying sol dash then a number login. Has anyone tried that and found it didn't work? Has anyone tried it and found it did work? Yep. Okay, so you're going to log in as root, R-O-O-T. Yep. And then the password, hopefully, if I've got them set right, is GENIVI 1234. Lowercase. Let me try it. Oh, so I don't type that there. Oh, I timed out. Try that again. So, have we managed to log in?
No, they need the user password again.
Root. The user is root, R-O-O-T. GENIVI 1234. Bigger. I'm going to type that bigger. I tried that. Didn't seem to work. Oh, command plus. No, that's not working. Not in text, mate. Is it working? Yep. In?
Yes.
Okay, super. All right, so I'm sorry if you've never used a command line before. This is going to be a bit strange for you, but you're going to type cd to change directory, then slash, then source, then definitions. I wonder if I can make that bigger. I can't get it bigger. All right. And if you ls, there you should see a list of files. So I'm going to now show you on another browser screen what is in that directory, just so you can get an idea. So this is a web-based interface onto a set of Git repositories. It's called git.baserock.org. And if I come back to that first picture, this is the process of collecting all of the upstreams that we care about. So the Linux kernel, systemd, all of those Unix programs originally, all of the open source stuff that goes into making the GENIVI demo platform. We collect in one place and we put it all into Git. So this is a web interface onto that Git set. And then the directory that you're in on that server is a checkout of a specific repository called definitions. So if I look in the tree in this, you can see this is the actual directory that you're seeing when you're logged into that server. And within there, we have definitions of components, groupings of components, and systems. So the system we're going to care about today is the GENIVI demo platform. And as you can see with Git, we're able to have lots of different versions of this repository. The actual version that you've got checked out in the directory that you're in is this one, which is the tag that we released for GENIVI a week or so ago. And when that comes up, it's taking its time. So what you could do in your directory is cd into, or you could ls systems. Still working? Server's not working. Is my connectivity working? Is anything working? No, network's down. No browser, nothing. That's a wireless one. Oh, it's back now. Right. No. Is everyone else still in their servers? Yeah, lucky you. If you list the systems, you can see that we have lots of definitions of systems. And the one we care about is going to be this GENIVI demo platform, ARM v7 LHF-Jetson. So this is a description of the software that makes up the GENIVI demo platform. And if I come back here, now we finally managed to check it out. I'll show you the file here because it's easier to see in this browser than on a command line. So, as you can see, the system is described in YAML, which is about as tidy as we can make it. So the aim is that we can make it easy for humans, people, to understand what's in the software, but also easy for the computer to interpret what's in the system that we want. So this is a list of things. It's got the kinds of things that you know are in the GENIVI platform. So it's got Qt, it's got Mesa, it's got Western, it's got Wayland, it's got various things specific to GENIVI, it's got multimedia, it's got the set of software described, okay? And then for each of those descriptions, we have specific lower level descriptions of what's in them. So if I look in this strata directory, you can see that if I choose one of them, for the sake of argument, Qt, in YAML. So all we're saying for each individual component, we're going to say where we're getting the repo from, which is, this is a reference to the set of Git repos we've talked about. This is the specific checkout version that we want, and any things that need to be there present when we build it so that we can get the dependencies to line up. And that is the same all the way down the stack. And one of the things that we managed to do tidily with Baserock is get to a point where we can say that the whole stack works for multiple architectures, and we've properly isolated the BSP. So the GENIVI demo platform for the Jetson, it's the same stack except for the BSP for the Jetson. We are very confident that we can make the same thing work on the Porter. We can make it work on the x86 boards. We have achieved that isolation by being native. So back to the actual session that you're in before it times out. You're going to run a command. Let me just find it from here. So you're going to run that command there. And it has tab complete. This is a trick for people who've never seen a command line before. If you type tab and the command can be recognized, it'll find the rest of it. So in your session, you should be able to write /source /ybd /ybd, and if you just type that, you should get ybd.py. Are we there so far? Then you're going to type systems, but sy and tab should get you systems if you're in the right place. Then G should give you GENIVI, the tab. Demo platform is D tab. And we want one of the ARM versions, and there's only one ARM version for this demo. Okay. Then you're going to type in that section again. So because we have to specify the architecture that we want to build for, ARM v7 LHF, which is ARM v7 little endian hard float. We can support building this thing for big endian systems, for example, or without hard float. So the architecture needs to be specified. And in theory, if you just hit enter, that should work now. So the tool we're using, YBD, it's quite chatty. It's going to report lots of warnings. You don't need to worry about those. It's just telling you things about what's going on. If it's actually going to stop, it'll stop with an error. So warnings don't matter in this demo. So has anyone managed to start that program? Does it seem to be doing the same for you as it's doing for me? That's cool. So imagine the miracle. Here it is, 2015. You're on an ARM server in the cloud somewhere in France, from Korea. You're being broadcast to the internet, and you're building the GENIVI demo platform from scratch. Okay, now in the hands-on yesterday, it was pointed out that there would be no point in actually trying to build the thing because it was going to take 7 to 12 hours. Okay, frankly, that would be the case if you tried to do it on an ARM server too. Okay, but we're not going to do the whole build. So depending on which server you've got, you may have different results. So in this case, within a minute, it's told me it's already built that. There's already an artifact describing that system built in this server. Okay. You might find that it takes longer to do the cache key calculation. Cache key is every single artifact, so we're working out a unique identifier for everything to say, for this version of Qt, we're going to need all of these dependencies, and then you end up with a unique defined identifier for that. So then the servers that you're using are all connected to another server, which is acting as a delivery engine for those artifacts. So, for example, if I do Qt star on this, you can see, I hope you can see. So this is another one of those ARM boxes, and all it's doing is holding copies of all of these artifacts so that they can be delivered if one of the servers needs them. Okay, so this is designed to be used inside the kind of organizations that do automotive software, where you have many people working on the same thing. You don't want to be all building the same thing from scratch. So can I just get some quick checking from Pedro of whether people are managing to actually get the YBD process to work? So in some cases, if you don't already have the artifact, it's going to be downloading the artifacts to your machine if it can find them on that server. If it can't find them on the server, it's going to build them locally. Okay, building Qt WebKit on any box takes way too long. When you put all of these things together, we have something like 350 components to get to the whole GENIVI demo platform. So it does take some hours to build the whole thing. But by using the caching and by not rebuilding stuff, we can bring that process down a lot faster. Any questions so far? Silence. That means it's all working fantastically well. Oh, is that for GTK? Yep. Okay, so here's an interesting thing. There is a tiny bug in the git.baserock.org processing of the resolution of trees, okay? And I believe that because there's a plus in GTK plus, right? If you look above that tab, it's saying, warning, no tree found, right? So that's because we've said to the API on the Git server, can you give me the tree for this? And it's saying, sorry, you've got a plus in that. I'm not parsing you properly. So then it's now doing the fallback process, which is to say, well, give me the Git repo, I'll work it out for myself. And it should achieve that. And then it will do the calculation, and then it will proceed and do the build. So I deliberately didn't set all of these machines up the same, because I prefer chaos. So we've covered the broad concept. We are building everything from YAML. The tooling that you've run, the YBD code, it's 2,000 lines of Python. And setting it up, all of the instructions for creating a scaleway machine and doing the setup of this, it's all on the Baserock wiki. So I've done the specific instructions for this server on a new page representing this hands-on, but most of this information is taken from other pages in the Baserock wiki. So it's relatively easy for you to find and reproduce the environments that we've actually used here. So to be clear, everything I'm showing you is open source. There is no secret source, there's nothing hiding, there's no need for security. Everything is available in the open, okay? It may not be so easy to find. I can't say that the websites are perfectly laid out, but the information is there. And we are certainly happy to help people understand how to get started. So basically, after creating a machine, and I could show you this process now, I can create a server. There, it tells me €3 a month. And if that works, I choose my Fedora image. I create a server. And then that takes a couple of minutes to come up. You can see it's starting there. That's its new IP address. You need to set up your SSH key. This is for the full process, but since we didn't get enough, I didn't go with this approach for you. I'm waiting for it to come up. It takes about a minute or two. I'm patient. But you get the idea. Once I've got that new server up and running, I just install some dependencies. I install pip for Python. I install some more dependencies. And then it's all about just putting the software in there. So this was the specific artifact server which is that. And then this is the instruction you're running. Okay, so you would, with a little bit of time, be able to set up this whole thing from scratch yourselves. Okay. No, it's still going. How are our builds doing? Say again? Ongoing? What's it doing? Yeah, so it's now downloading artifacts. Okay. So the principle is that to get started, you are talking about assembling several gigabytes of information. But as a developer, you want to be working on stuff. So some of that information you're going to be changing locally. So until you've got the artifacts and the infrastructure in place, it is going to take a little bit of time to set up. But we've tried to simplify that as much as possible now, so that once that setup is done, you will have the Git repositories, you'll have the artifacts, and you're in a position where you can do work in a known environment. All of the builds that Baserock does are completely sandboxed so that they're independent of each other, and we can reproducibly say what went into one, and that as a result we know what's going to come out of it. Given that server's now come up, I'll just prove my point. Oh, and now we don't have any of this stuff, so now I would do the full instructions to set one up. That shell in a box is what we use in practice via the web. Anyway, that's just now installing standard software. So I guess we will have, do we wait for the downloads to happen on their machines? Do they need that in order to go into the Jetson now or not?
They don't have it.
Right, okay. So the idea of the main part of the hands-on, we've spent approximately half an hour covering the context and the background of how the process works, and we've tried to show you a way of doing the work in the cloud. You could similarly use your own laptop to build stuff. There's nothing magical about what we've set up. In effect, I've just created on that terminal. I'm in the process now of creating from scratch the environment that I would use to build stuff in. So you could do that in your laptop on your own normal Linux. If you're running Linux, you could run it in VirtualBox. You could set up Vagrant and do it. All of the approaches that people normally are using for Linux development are possible. So the further interesting thing that we're doing with Baserock is allowing people to develop on the board itself. It may not be obvious to some people that by the time we're putting together a quad-core ARM processor, it is actually quite powerful, and you can do real work on the board. And by doing the work on the board, you've got a faster loop time. So you're not having to go back to your laptop all of the time, okay? So what I'm going to try to do now is connect to this Jetson here. For the people that are sitting next to Jetsons, which I hope is most of you, if you're sitting at the back, you're out of luck, I'm afraid. There are still the possibilities of accessing some Jetsons down at the front, so you might want to come forward and do so. The Jetson is this box, so it's in a case probably, and it's got an SSD drive on top of it. I'm sorry that there's so much equipment in the room that this has been used for the other hands-ons. So each of the Jetsons has a serial connector, and in my case, it's converting to a USB. And I'm going to hook it into my Mac. I'll start a new terminal. Let's be different color. Okay. Now, depending on what your laptop is and how you normally connect to serial stuff, I can or can't help you, because I haven't used Windows for 5 years, and I'm not going back there. I did my 20 years of suffering on Windows. I was a Microsoft certified professional in the 90s. I'm never going to use that stuff again. I'm sorry. So on a Mac, you have Screen installed. On Linux, you have Screen installed. On Windows, Putty is your friend, I believe, but good luck with that. As far as I'm concerned, anyone that's working on Linux these days needs to understand Linux, and I don't think we should take any prisoners. If you're trying to do development for Linux from Windows, I'm sorry, but that is your problem, not mine. So, Screen. On a Mac, if you've connected anything to a Mac before, you will find that you've got, you'll have set up Screen to do this. If you haven't, you probably need some help at this point. So, is anyone unsure about how to connect to a serial connector to a board from their laptop that wants to do it? Sorry? You want to do it? Tristan, you know how to do it. So I've managed to connect to my Jetson, and I am there on a Jetson which is running a Baserock system. And in this case, the password, I think, is insecure root. I'm sorry? I'm sorry, say again? On the Jetson? Root backwards? Really? On the Jetson? Are you looking at the right box? Pedro, we've got a Jetson with a random password.
No. Which one?
TOOR is the password?
Yeah.
Oh, okay, no, it's not a problem. I'm just surprised. We normally, in Codetic by default, please hack this. We normally set passwords for things that we know are insecure to insecure, just to make it clear to people that it's an insecure password. So most of the Baserock systems that we set up have insecure as a password. So you managed to log in now? Yep, okay. So, oh, I've timed out. Oh, that's not working. I'm not getting in, am I? Oh, because I changed the password. Right, okay. So if you do uname -i, that will show you which Linux is running. And this is a version full kernel. We have an interesting thing on Baserock systems by default, which is the system version manager. And this allows you to see which version of a system is running. So we support the concept of having a live system and then other systems which we can flip to. So we're supporting atomic updates, okay? So by default, on the Jetsons, we've set up this factory system, which is a Baserock build system. So it doesn't have the GENIVI demo platform components in it. And I'm going to do, for the sake of argument, to free up some space. So I'm assuming that Pedro's covering everyone, and I can just proceed and talk about what I'm going to try to do. So back to the page for the hands-on. I am going to run the same command, so I need to go into source definitions again, which is where the code has been pulled. This is on the, I'm on the Raspberry Pi version. Why am I on the Raspberry Pi version now? Okay, so could you do git status? Let's make sure we're all in the same place. And see if you're at that state. You may not be, because as I said, I prefer chaos. Anyone struggling to get into the Jetson?
Only two.
Only two.
Have you managed to
Getting that?
only one?
Okay, so are we all at source definitions in a git checkout? And is it the GENIVI-K 1.0? Anyone that's not able to see that by typing git status? I'm sorry? Oh, you're in the Raspberry Pi. Okay.
Yeah, but it doesn't matter. It's the same version.
Okay, that's fine.
The Raspberry Pi version is
Yeah, fair enough. Okay. All right, so the command for deployment, and we're thinking about making this clearer, but at the moment it's the same command. The only difference is that if I go back to this and show you, so this was the YAML describing systems. Okay, I'll go back to the same place. So a system represents an image that can be run on a system. So that's kind of logical. We have the concept of clusters. A cluster describes a set of systems, or maybe it only a cluster describing the deployment of a tarball into a virtual machine. You know, how to convert from an image to a VDI file for VirtualBox or whatever. All of that kind of massaging of the core image to get it to a point where it can be used in a real situation, we do in a cluster. And a cluster can have many systems. So one of the areas of work that we're involved in is OpenStack, which is not automotive at all, but the concept there is you have multiple servers cooperating to do different things, and a cluster can describe the set of servers. It can say there's a host for this and these other servers that do that. So a cluster is one place to describe several things, several systems. So in the context of what we're going to do, right, yeah, okay. So we have a cluster here, which is describing the process of getting a system into a specific state on a piece of physical hardware. So this is the information that's needed for deploying to a Jetson. Okay, this says we're going to do it onto the Jetson that I'm already on. So it's a self-deployment. So the idea is that I'm already in a system. I'm going to create a new version of the thing I'm in, and then I'm going to be able to boot into that. And the system there, that describes the system that you were previously building on the ARM server. With me so far? Okay, so the difference then is instead of running YBD on the system definition, I'm going to run it on the cluster definition now, and that should do the deployment. Now, Pedro's just pointed out to me that this does not have a version label in it. Is there anything else? Right, okay. So, Vi or Emacs? If you're an Emacs person, you're out of luck. We don't do Emacs on Baserock by default. There's Nano. So I'm going to edit the deployment file. And in the deploy defaults, I'm going to put version label. Too hard now. Anything else I might have forgotten, Pedro? No. If you're ready, if you're ready and you manage to type that command line in, obviously I can just cut and paste it because I'm using the website. But that's what you're aiming at. And tab complete should work on the Jetson as well. So you're overwriting the firmware.
If there's a problem.
Oh yeah, if there's a problem, you're screwed. But there won't be a problem. This is Baserock. Okay, so this is now doing the full check. Sorry, let me show you. I can't go back. Up scroll doesn't work here. So the command, in case anyone missed it, that's the command you're going to be typing. So instructions for setting up a Jetson are also on that on the Baserock website. Let's find them. Come on in.
Well,
yep.
You need to put something, an error when you put the wrong architecture.
Say again?
you need to put an error or raise an error.
Oh, someone put the wrong architecture.
Yeah.
Oh dear. That'd be a
So,
shame.
that doesn't fail. You just say it's successful.
Okay. We found a bug. Excellent. Presumably it didn't deploy though. I've just been told that if you specify the wrong architecture, it claims to have succeeded, but it can't have actually deployed anything. Note to self. Yeah, it is going to take 10 minutes. All right, so I'll just briefly cover that. So if you get a Jetson from retail, then it comes pre-installed with Android. So you need to go through a process of flashing it. This is a reasonably well-trodden path. We've done this quite a lot. So I hope that those instructions are pretty good. But it is going to be before we've isolated the BSP properly. So it is possible to do work on the x86 GENIVI demo platform and expect that it's going to work pretty much straight out of the box once you migrate it over to Jetson. So you can use a faster cycle by developing on the fastest box you've got. And then once you've got to a point where you need to test, do that final process on the board. But you've got the option of working directly on the board for those odd things where, oh, there's something wrong with the driver, or oh, the screen doesn't look exactly the same, or whatever it is. Okay, so after doing the cache key calculations, it should eventually start the deployment. So you should see this starting deployment. And then that process now is it's unpacking the system image. It's creating a new partition for that image to be existing in. And then it's going to do the process of configuring that so that next time the Jetson boots, it boots into this new image. At least on mine, and I'm not sure about the rest of the Jetsons, I'm going to have to enter the password for root 10 times. Nobody else, just me. This is why I changed the password. I have to type it lots of times. So, as you can see, it's only 2 letters long. Less chance of me getting it wrong. So hopefully for you, you're not having to type any passwords. Any questions about what's going on? Is it clear? Cool. Do a process of modifying something in the HMI. And frankly, I've not actually done this. I spend so much time doing other stuff. I haven't actually done any real work on the GENIVI demo platform in my life. So there we're going to be in truly uncharted territory. However, I do believe that there are instructions, and I'm going to try to follow them. So a colleague of mine wrote this, which is instructions for modifying the HMI, I believe. And I'm going to try and do that. Let's see how it's cooking. Still deploying. If anyone gets the deployment finished before me, please let me know. You're rebooting already? Cool. So we're not suggesting that this particular deployment method is production ready, but it's designed for production. So the idea is that you can choose your own atomic update mechanism, but the whole principle is clearly better than installing loads of packages and their dependencies. In the context of the development environment and the GENIVI demo platform, we're using BTRFS for the file system, which means that we can use snapshots to get between these different versions, which makes it relatively painless. For production, you'd probably be using a different file system. You'd probably need a different mechanism. But for anyone that has managed to achieve the deployment, once you've done the deployment, if you type system version manager list, and it should show you the new version as well as the old version. I can't do that yet because it hasn't finished. I don't have system version manager on my laptop. List, they should see that yep, okay. So then it should be, you should see that you're currently running the factory system, and you're and return, then it should go through a process of rebooting. And hopefully if there's a screen connected to your Jetson, you should see it coming up. It will give you a choice to choose which version. So even though it's set for the default, you don't have to choose the default. You can boot into the other one. But I think you'll be choosing 2 in boot to get to the GENIVI demo platform. And I'm going to wander away because I want to check some screens and make sure that this is actually happening. What's happening? Cool.
These jets. Yeah.
I guess mine's slower than everyone else's because I've got to type the passwords. So it should be possible to actually interact with that GENIVI demo platform using the mouse, I believe, if you want to try that. How many Raspberry Pis have we got?
10.
How many are set up?
Just 5.
Just 5. Okay. Who wants to boot the GENIVI demo platform on a Raspberry Pi? Don't all jump at once. We were told everybody wanted Raspberry Pi because it's too hard to get the kind of hardware that people use for the GENIVI demo platform. So, works for both Jetson and for Raspberry Pi. So, do you want to try? Yeah. Okay. We've got half an hour left. I think it would be more fun if we do get at least one person to achieve the Raspberry Pi process. So I'll describe that first, and then if we've still got time, I'll cover the modifying software. Okay, so No, we only have one volunteer.
Okay, then I will go with that. You can continue with
All right, fine. So back at the Jetson then, you should be able to log back in on your console and reboot. You will need to reboot back into the other partition. So you want to boot back now into the previous Baserock system. So that means choosing 1 at the boot menu as opposed to 2. So I haven't done the reboot, but if I do the reboot now, I'll show you. So instead of booting into number 2, I'm going to choose number 1, which will bring me back into the place I've just been at. So I've not bothered going into the GENIVI demo platform on my machine. And get back to source definitions again. And the Raspberry Pi version, I need to do a different git checkout. So that will be the command if you're going to work on the Raspberry Pi. So right, if you're not going to do the Raspberry Pi, you don't need to do this. You're going to stay with the GENIVI K1. Right, you don't need to set the Raspberry Pi up yet because you're going to be creating a different image in the meantime. So we can do that after you've got the thing started. So that now puts you in the Raspberry Pi. Oh, actually, that's the wrong command. I need to fix that. Right, so the command you're going to run to do the deployment for Raspberry Pi is that one. And it's the same principle as what we've done before. So the only difference now is we've got a different cluster describing how to create a system to deploy on Raspberry Pi. And in that case, what we're doing actually is describing a tarball, let me just check. Okay, so the difference, if you're working on the Raspberry Pi, is only in the cluster. It's describing how to put together, well, and the BSP, I assume.
Yes.
Yeah. Okay, but this describes taking a different system and deploying it in a slightly different way. It's creating a raw disk, and it's setting the bootloader format and everything else for the Raspberry Pi. So that's the difference. Everything else above the BSP and the cluster is the same. So when YBD runs that command, it will check if it needs to create a Raspberry Pi image as opposed to a JSON image, and it will do the build if it needs to. So one command will build if it needs to and deploy if it needs to, provided you give it the cluster as a target. Okay, so most people said they weren't going to do the Raspberry Pi, so we're going to try and do the other thing, which is let me get back to here. And we're now going to try and do an edit of one of the components. So the component we want to modify is the HMI itself. So you could, for example, find out where the HMI is. And that will tell you which files deal with the HMI. And it's actually this description that we care about. We're going to modify.
Do they need to be in the factory version?
They should have booted back in the factory version.
Okay.
Yeah.
Because not everybody.
Okay. Okay. So I can find the HMI. And this is where, so by default, it is working from a given branch or a given checkout specified in this YAML that's pointing at the Git server that we're using. In this case, we actually want to work locally. So we're going to specify that we want to work with a file instead of HTTP. And then we need to specify the location of the Git checkout that we're going to use on the local machine. Okay. So that leads strangely to an extra slash. We're going to specify it from root of the disk we're working on, of the file system we're working on. And then I'm going to create at random GDP, I don't know, SEOUL. Whatever string you put there, it's up to you. Okay. And then I'm going to say head for the sake of argument. Or I could say master. With me so far?
There are some people running the GENIVI platform.
Well, if they can do this edit, that's fine. We can reboot after we've done that. Okay. So right. So I've set, instead of repo pointing to the upstream repo that I'm using, I've set that I want to work on a local version that I've checked out here. And I'm going to work in whatever is the master that is in that repo. Okay. Now, if you're in the GENIVI demo platform and you type Git, I bet you haven't got it. Have you got it? Does Git work in GENIVI demo platform? If it doesn't, you now need to reboot. So you type reboot. And then you go and you choose system 1. So you get back to the default factory system. Okay. Assuming you're in the default factory system, then Git should work for you. Okay. So cd/source. Actually, no, I don't need to do that. I can do Git.
Follow these.
Say again?
People is managing to follow these instructions.
All right. Okay.
I didn't think so.
All right. So. Okay, Pedro is saying that people are not managing to follow. So I'm going to start again and try and make sure that I've covered what you need to cover for doing the edit, okay? So are we all on the command line? Anyone that's following along, raise your hands, or trying to follow along. Don't be shy. Okay, anyone who isn't following along, raise your hands. Right, you're all following along then. Okay. Right, I edited that file. Are we able to edit that file? let's go back to the beginning. Git reset hard head. Since we're not going to be doing deployment this time, we won't need to fix that cluster again. Oh, I'm in the wrong branch as well. Okay. So the commands we're going to try are git checkout GENIVI-k1.note, which should put us in the right branch. Status should prove that we are there. And git reset --hard head to make sure that any accidental edits we've done get blown away. So we should now be in a known state, which is the GENIVI release that was done last week. Okay, with me so far? So I'm going to edit that file, which you could achieve by doing vi or nano or whatever you're using, then just typing strata and b tab, demo tab, locally. So file, // and then we need the directory that we're going to use. So I'm going to make one up. So it's going to be in /source, and it's going to be foo, for the sake of argument. And then I'm going to delete this and put that to be head. I'm going to save that. So that's the actual change I've made. Replace those two lines with that. Okay, now I'm going to find the HMI repo locally. So it should be already down in one of the many Git repos we've got. We've got /source/gits is a load of Git repos. And there is one called HMI. HMI. And I want to make a new checkout of that, so I'm not going to tamper with what is being used by default. So I'm going to do git checkout source gits that, and I'm going to check it out into /source foo. What's happened there? Oh, because I was in a Git repo. Oh, git clone. Sorry, I'm typing a stupid command. I'm an idiot. So all that's doing, in the process of building, we've ended up with Git repos on the local file system. I'm now just making a clone of one of those so that it's in an isolated place that I can do my work in. And in /foo now, this is the actual HMI for the GENIVI demo platform. Now I could make some changes here. I don't know whether my colleague described any specific ones, but the principle is you do your work in that local Git repo, and then you go back to definitions, and then you run YBD. It will build with your local changes, it will create the image, and it will deploy, and then you boot into that. There is the possibility of having the GENIVI demo platform with enough tooling on it so that you can actually just untar in place. So depending on the kind of change you're making, and this is described on that workflow page. Let me just find that. There is the possibility of, so this is the process I've just described. So we've modified to say we're going to use the local checkout instead of the thing from the server. Then we build it. And then this is the possibility of extracting. So in effect, we can just take our modified artifact, which is what gets created when YBD runs. So you can see the output. For example, in one of the lines, if I were to run this now, it would build this, and that would be the thing that would change. Okay, so this defines the artifact that's created as a result. And if I show you all of the artifacts we care about get created there. Okay, so it would be possible for you to take one of these and just untar it, because if I take one, if I take the HMI, for example, each artifact is stored in a subdirectory. So if I look at the one that's been built, underneath that, there is a tarball instead of doing a full system image create, you can just untar it in place. Okay, so need that twice -C, and I would untar it into place in /. Now that's very dangerous. For example, if you were to be about to do that to the kernel while you're running the kernel, that would not be a good idea, right? You would want to go through the full process of creating a new image and rebooting into it, right? So depending on the kind of work you're doing, this may or may not be a safe thing to do. But for changing the HMI, it clearly is safe, because we expect the system to be robust against us fiddling with the HMI stuff. So there is a reasonable set of use cases where you can achieve what you want just by doing that. So here is the example. And obviously, depending on what you've done in your change, this cache key will be different. If you've made changes which affect anything, then the cache key calculation is going to create something new, because we don't want your change to be believed to be the same as everyone else's. Okay, so that would be the whole process. You would do the checkout. You've edited the instructions to point to your checkout. You would make your changes. You would run YBD to build it again. And then all that you get from that is an artifact, and then you can untar it in place. Okay. I don't think we can make it any simpler than that, although we will keep trying. And as I said, all of the instructions for what I'm doing are on wiki.baserock.org, so that it's not completely indexed yet. We've not sorted out the homepage to point at all of this, but the files for all of this are available. There's nothing that we've just hacked together for the demo that you can't reproduce. Okay. So it's 10:15. We're due to finish at past. I think I've managed to cover the process of getting started. You could, from the instructions that we've provided, get yourself an ARM server in the cloud. You could set it up to run the Baserock stuff. You could build the complete GENIVI demo platform from scratch. There are even instructions for creating the artifact servers. We've gone through how to run in place on the Jetson and do a build and a deploy there. And the same process can be applied to create a deployment for other boards, for example, the Raspberry Pi. It's running on the Raspberry Pi. Congratulations. Well done. That's a result, I believe. So I think we've kind of covered everything I was hoping to. I'd be very happy to take any questions or finish early. I've live cast this on receive feedback. If there isn't anything that's if there's anything that hasn't been understood, you're welcome to ask questions. We're on IRC, on HashBaserock on Freenode. We have a mailing list, and we are very happy to help you get started, understand how to do this stuff. Okay, any questions? And if not, I'll close the session. Yes, okay. So Jakob's asked about the artifact cache. So we've gone through, Baserock's been going now for 4 years, and we've iterated on a lot of this stuff. We've tried to work out how to simplify it, okay? So I don't know whether we've succeeded in simplifying it enough, but it is simpler this year than it was last year, and it was simpler last year than it was the year before. So the artifact cache, the code for this, YBD. There really isn't very much of YBD. So the tool you've used, this one repo includes both the tool for building and deploying, and it includes the server code for running the actual artifact cache. Okay, so YBD is the tool that you've run. KBAS is the artifact cache code. Okay, and as you can see, there isn't very much of it. That's all of it. It's a bottle app. So KBAS is keyed binary artifact server, right? It will respond to a few things. So if you don't put anything in, it comes back and just tells you its status. So it's saying how much space is on the file system it's sharing, how many files it is offering to serve, and when it was started. Okay. If you put star, it shows all of the artifacts that it's got. Okay. And this is just a user interface to help people understand it. It's not really for users. It's to be queried by YBD or some other tooling. Okay. But I can, for example, find Linux star artifacts. Okay. Or I could find artifacts. Okay, so it's a normal bottle application, and all it's really doing is serving a directory. So in, let me see, where did I go? There. And the source is on GitHub as well as on github-baserock.org. It has a config file, which is very simple. So basically, you tell it what directory you want it to serve, and you tell it what host it wants to publish as. 0000 means whatever is the IP you can get, please just present from there. You can specify the port. And by default, the password is insecure. Weirdly, because that would obviously be stupid to have public code that has an insecure password. If you run KBAS and you don't set the password to anything else, it will never accept any incoming stuff. You need to change that password. Okay, otherwise nothing uploading to it will get anything changed. But basically, you just run it. Do I have an example of that? So the typical situation would be actually, the design is to cater for two different use cases, or at least two different use cases. One is a situation where you have a long-term need to serve artifacts to a large bunch of people, and then you would run this once on a real server. But there are other simpler use cases where Fred has built some stuff, and then for a while he wants to serve those artifacts so the rest of his team can get them. So you can just run KBAS on the machine that you did the build on, and publish. It will publish from there, and then the other developers can set their machines to point at that temporarily to download the artifacts. Okay, and that will be achieved by, in YBD, setting the config for YBD. Now, the default config for YBD is a bit more complicated. It's doing more things. Right? But it has the possibility of a KBAS URL and a KBAS password. Okay. Now, you can either modify this in your YBD setup, or you could create a new config file which will override this in the directory that YBD has been installed in, or you could create a config file in the definitions directory, and it will go through and choose which of those, and it will apply them in order. So it will start with the default, and then anything you override will be applied. Has that covered what you needed, Jakob?
How do you handle meta information? Is this already in, or is this something?
Yes, okay, meta information, right. So we're still working in progress on that, but I think we're doing something interesting. So find one at random. So cd. I'm now in an artifact directory. And this is one of the artifacts untarred. Okay, so unpacked means it's the untarred. So okay, so every Baserock artifact is just a tarball of something to be stuck onto a file system. Okay, so this would be untarred @ right? And every Baserock artifact has a Baserock subdirectory. And in the Baserock subdirectory, we put the metadata that we care about. Okay, so we have another tool called Morph, which does a more comprehensive metadata process than YBD does. YBD is aiming to be the fast hack solution at the moment, although we could extend this metadata relatively easily. But if I look at Baserock, you can see that there is a meta file describing what constitutes zlib. So if it's a very simple metadata scheme, but it basically says this is all of the stuff that we end up with. We could extend that, we could put checksums in for everything, and so on and so forth. But in effect, it's saying that's where we got stuff from, and that's the ref that was used. Okay, and there is no real support for hacking in the context of Baserock, in the sense of you can't use this tooling to create some stuff that didn't come from Git. Right? Do you see what I mean? So that does represent a unique identifier of the code that was used. And that, plus all of the other metadata from all of the other things that went into it, gives you a clear indication of what is in a given system. Right? So it is possible for a Baserock system to probe the /Baserock directory and know for sure every single component that's in there. Okay. Does that cover it? Yep. Okay, great. We have 5 more minutes. Any more questions? No. Okay, well, folks, thank you very much indeed. I think it's gone reasonably well. Cheers.